This is Sprint 2 for Team GVR Bot. This is the GVR Bot team to include Nico Tan, Braden Bansky, Jake Moffitt, Zach Vosberg, and Steven Uehara. Our goal for this sprint was to develop test plans for data collection, conduct tests to load SMBus data to database, conduct tests to load the multimeter data to usable file, develop a method for tracking distance traveled on a desk test, and develop paper prototypes for the web app.
Hi, I'm Cadet Bansky, EE major. My primary goal is to connect the DMM to the usable file, and my secondary goal is to implement the tick counter.
My name is Cadet Moffitt. My goal was to fabricate the PCB, connect with the SM bus through the Raspberry Pi, and implement the code for the tick counter.
My name is Cadet Tan. I parsed the SM bus data using the Raspberry Pi and utilizing Python modules. My secondary is making the paper prototype.
My name is Cadet Uehara. I'm a CS major. My primary goal is to implement test plans, also to connect speed testing, and to do research on the ROS code.
Hi, my name is Cadet Vosberg. My primary goal is to implement test plans. I also conducted speed testing and then looked at the ROS code for battery code analysis.
Here we have our burn down chart for this sprint. As you can see, our capacity was 96.5 hours, and we completed a total of 97 hours.
Here you can see our requirements analysis. Our main goal is to develop a model that a robot can use to gauge how much battery life it has left based on changing environmental situations. The feasibility model is going to be the way that we accomplish this. And our user interface will be through the robot, since the robot is going to be making decisions based off of the model. Here are our specifications and the constraints that we are limited to with our hardware.
Here we're conducting a test to load data from the multimeter to a usable file on an Excel sheet. We are sending the data from the multimeter through a USB to the Excel, in which it can take intervals of either hours, minutes, and seconds, voltage or current readings, and it will log it into a chart over time.
This is the Raspberry Pi with a configured breakout board that connects to the SM bus. The Raspberry Pi itself collects and processes the data using Python modules such as MySQL database and SMBus2. Here, we are going to run the parser code that will collect the data from the smart battery and input the data into the pre-configured SQL database. The source code can be found in Trello or on the GVR SharePoint. Here is the data collected from the smart battery through the SM bus presented on a SQL database on the Raspberry Pi. The data collected is as follows: time when the data is collected, temperature, voltage, current, relative state of charge, and absolute state of charge of the battery.
To track distance during desk tests, we have designed a tick counter that will increment one by one every time the treads complete a full rotation. Here you can see our implemented tick counter. On each revolution, our tread marker actuates a wire switch, completing the circuit and incrementing the counter. The Arduino Nano used runs a lightweight code that monitors whether the circuit is completed. Here you can see the output of our tick counter using the Arduino. Here is a printed circuit board that we are using to replace our SM bus interface here. Currently, we have the SM bus connected to the Raspberry Pi through a proto board, but for sake of durability, we would like to move it over to this PCB. We're also going to be able to connect the power for each cell on these two sets of posts to the robot through this board as well.
This is our prototype for the web application. Our goal for this web application was to create an environment that will display data collected during tests in an easy-to-access format. We have currently filled it with example data that we might see in our tests. To begin, we first have a window that will display all of the data collected within a test. From there, we have several graphs that will portray how our tracked variables reacted over time. These graphs include a graph of the current, the absolute state of charge, the relative state of charge, and voltage. This concludes our demo of our web application prototype. This is the product roadmap for GVR Bot. We have just completed Sprint 2, in which we created test plans, prepared features in GVR Bot to be ready to conduct tests, as well as develop paper prototypes for the web app. We're now looking at Sprint 3, in which we will conduct tests for speed and load, as well as develop the framework for the web application. In reflection of this sprint, we were able to complete all of our sprint goals. We developed test plans for data collection, conducted a test to load SM bus data to the database, and conducted tests to load multimeter data to a usable file. We developed a method for tracking distance traveled on a desk test, and developed paper prototypes for the web app. For next sprint, we will conduct tests for speed and load, as well as develop framework for the web app.